Okay, so to start, we're going to talk about tangent really quickly. And then we're also going to talk about the new trig ratios. Now, when we first learned about tangent, we were working with the slope of a line, right? It was some rise and run value for different slopes. And when we had a line like this, a diagonal line like this, and put it against a horizontal line like this, there would be an angle that would be created. And one thing that we noticed was that when we had different side lengths over here, so different rises or different runs, the angle would change. So for example, when the rise was 1 and the run was 5, there would be an 11-degree angle created over here. Or if we had a rise of 2 and a run of 5, then the angle would be different. It would be 22 degrees instead. And the trig ratio, so we've first learned about it as a slope ratio, right? And it was this rise over run, which in this case was 1 over 5. So we call this the slope ratio because if we evaluate this, right, it would just be 0.2. It'd be some value. So we would say that when there is an angle of 11 degrees in some triangle, in some right triangle, the side opposite of it and the side adjacent of it would create a ratio that would equal 0.2. That was like our beginning understanding. And it's the same thing over here. When we had a triangle and we had an angle over here, which was 22 degrees, there would be the opposite side and then the adjacent side, right? This is 2 over here, this is 5. It would create a slope ratio. So slope ratio, let me read that. So slope ratio of 22 degrees is going to be equal to 2 over 5. So that was what we first started learning about tangent. Then we came up with the actual terminology, which was tangent ratio. This was like the proper name for what we had over here. So the tangent ratio is going to be defined like this. Say we have a triangle, it's a right triangle, and then this is going to be our reference angle. We'll call it theta, which is going to be looking like a 0 with a dash through it. We'll call this side y. We'll call this the opposite side, and we'll call this side the adjacent side. So the tangent ratio, so we use this thing which was like the tangent function. If you take the tangent, in this case tan, of that theta, right, that value would give you slope ratio of the opposite side over the adjacent side. So if we said, so for example, using the numbers that we have up here, if we took the tangent of 11 degrees, we would get a value that is the same as 1 over 5 if we were to evaluate. The, um, the tangent ratio has a bunch of different ways to use it, right? When we first introduced it, we had our triangles. We would get some value here. Let's call this 35. And then we'll say this is 5. And we'll say this is x. So when we started using the tangent function, we would set up the equation because we're setting up the same ratio, except now this tangent function is calculating the value that's already given for each angle. So if we take the tangent of 35, right, that's going to be equal to the opposite side divided by the adjacent side. Or in this case, that's tangent of 35 is equal to x over 5. And then to solve for x, we're just going to multiply both sides by 5. The 5 at the bottom cancels out the 5 at the top. And then we have a new equation where 5 times tangent of 35 is equal to x. So this was like the stuff we talked about last semester. We're using where we start talking about some slope ratios, how there's a different angle when we have a different rise and run, right? And then we got this idea of it's actually called a tangent ratio. It's something that works with triangles, where if you have some angle over here, right, there's always going to be some given ratio of the sides opposite of it and adjacent of it. And that's something that we already are able to calculate. So if you take the tangent of this unknown angle, right, it's going to spit out the opposite side divided by adjacent. That's why we have this setup to begin with. I'm going to pause for 1 second. Hopefully everything I'm writing down is coming out clearly. I think I need to refocus my document camera. Okay, that looks way better on my screen now. Okay, so just take some time. You can pause the video, you can rewind, see what you need to figure out. But all this information, it just kind of snowballs into this final thing, which is the trig ratios, which is tangent. Now let's do another example with tangent. I'm not going to calculate this, but I'm just going to leave it as is. But if you wanted to calculate it, I'll use my phone calculator. It's going to be different than the calculators we have at school or in any classroom. Oh, you can barely see it. Okay, so we would do 5 times the tangent of 35, right? And then that's going to give us a side of, so x ends up being 3.5, and we'll just keep it at that. So now we know that when you have an angle of 35 in a right triangle, it's so tangent of 35 is going to have some ratio of the two sides, the opposite side over the adjacent side, equal to 3.5 over 5. Which is basically 0.7. It's just like 7 over 10 if you like multiply it by 2. So like if you multiply the top and bottom by 2, it just becomes 7 over 10. That's kind of a way of simplifying it. Okay. One away. So let's do another example, but in a different way. So say we have a triangle. Okay. Now the reference angle is up here. Call this 23. We'll keep solving for this side, so we'll keep that as x. And then we'll say that this side is 7. So now that the reference angle is shifted, we have to change the way we think about our formula. You can kind of like flip it. I mean, now the numbers are to the side, but you kind of have a similar scenario, right? This 23, opposite side is 7, and then the adjacent side is x. So we take tangent of 23. It's going to be equal to the opposite side, which is 7 over x. Now this one's going to take a little extra step, so we'll do slowly. So I'll rewrite here with some space. The first thing we want to do is just say there's an imaginary one over here. We're not going to cross multiply at first. We're going to do it step by step. So the first thing we want to do is get rid of x from the bottom. So what we can do is multiply x on both sides. So x over 1, x over 1. The top x and the bottom x are going to cancel out because they're just going to equal 1. And then we're left with x times tangent of 23 is equal to 7. Now we still need to get x by itself, so we're going to divide both sides by tangent of 23. And remember, even though tangent is a function, tangent of 23 is still some known value. So this is like some number. So if you divide a number by itself, it just becomes 1. So these cancel out, and we're left with x is equal to 7 over tangent of 23. All right, let's go put that into my calculator. Do 7 divided by, and I like putting it in parentheses. Anytime I'm dividing by something. Okay, so 7 divided by tangent of 43 gives us 7.5. Okay, so we've got two different ways to apply tangent. Remember, tangent of some angle we'll call theta is always going to apply whenever we have when we're given an opposite side and the angle, or the adjacent side and the angle. And I'll mention this later as well, but just to review, you only use tangent when you're given an angle and then either an adjacent side, which we have in this case, or an opposite side, which is in this case. So we're given an angle and then we're given the opposite side. It's always going to be the case that you're going to need two pieces of information in order to solve for a missing value when it comes to trig ratios or anything to do really with triangles like this. You're always going to need two pieces of information. If you can't get two pieces of information, it's kind of hard to figure out all the other missing sides. And then by given, we're always getting a 90-degree angle. So even if you're given if you're given one angle, you can still find the other because that's two pieces of information. All right. So I'm going to talk about the new trig ratios. So we have, I'm actually going to write all three trig ratios and then the specific parts. So we first started with tangent of some theta, which is just some unknown angle. Its ratio is always going to be the opposite side divided by the adjacent side of a triangle from the reference angle. Then we have sine of some angle, right? This is going to be the opposite side of that angle, then the hypotenuse. And I'll draw another picture too, labeling sides. And then cosine is going to be the adjacent side of the reference angle divided by the hypotenuse. So if we have a triangle like this, it's a right triangle. Let's call this our reference angle. So this side is going to be the opposite side. This is going to be the adjacent side. And then this is going to be the hypotenuse. Now, whenever we have a triangle or a right triangle, the sides of the triangle, so like the horizontal and the vertical side of a triangle, we can refer to them as the legs of a right triangle. So this is like the leg, and leg. Now the hypotenuse, it's not some special name that has something to do with the reference angle. It's an actual like term for a part of the right triangle. It's always the longest side of a triangle, and it's going to be always a diagonal one. It's always like this. This is the hypotenuse. This is never a hypotenuse. This is never a hypotenuse. This is always a hypotenuse, and it's only for right triangles. So let's do some practice problems on when to use each of the trig ratios. All right, so if we have some angle here, let's call it 47. Now, I'm going to label one thing. So if we're given our angle and there's some unknown that we're solving for, in this case, the unknown is our hypotenuse. So I'm going to put my trig ratios here. And then we're going to kind of do a game of elimination. So I'm going to just completely write out the ratio, the equation that it would be. Okay. So we're given an angle. It's a good thing. They all have angles. So right now we're still using every possible option, but we're solving for x, which is our hypotenuse. Because tangent doesn't have the hypotenuse as a part of the ratio, we're going to cross it out. It's not an option we can use anymore. Now, if I said that we're given 5 over here, right? This is the opposite side of this reference angle, right? So we have a hypotenuse, There's an angle here, there's an angle here. So far so good, but we're given the opposite side of this angle, which means we can't use cosine. We have to use sine in this case. So let's use it. We're going to set up our equation. Sine of 47 is going to be equal to the opposite side divided by the hypotenuse, right? And we're going to solve for x. We'll we'll multiply both sides by x over 1. This is going to cancel out here. That's going to cancel out there. We're going to left with x times sine of 47 is equal to 5. Now we want to get x by itself, so we'll divide sine of 47 on both sides. Those will cancel out. And we get that x is equal to 5 over sine 47. So plug it into calculator. Okay, so we're going to do 5 divided by sine 47. So that gives us our hypotenuse, approximately 6.8. Now, because we're only given this information, we're working off of information we're only given, but we can still use cosine as a method. Now, what you could do is you could say that because this is 90 degrees, right? So we have 90 degrees, right? We have 47, and we know that the interior angles of a triangle are equal to 180, so we're going to do 180 minus 90 plus 47. So 180 minus 90 plus 47. And look at that, it's 43. So our missing angle is going to be 43 up here. Now, if we use the angle 43, then we can use cosine because now 5 is adjacent to 43. So we'll do cosine of 43 is equal to the adjacent side, which is that 5 over here, because it's right next to it, divided by x. And then we're going to do some steps to get that x by itself, just like we did with sine of 47. Okay, and then we'll divide both sides. Oh, skip the step. We'll divide both sides, cosine 43. And that's a little messy right now. So it's going to clean up, these cancel. It's going to be x is equal to 5 over cosine 43. And let's see if we got the same thing. 5 divided by sine 43. Look at that. Ooh, you see that? There. Perfect. We get the same exact answer. We got 6.8. X is equal to 6.8. We use two different methods to get the same exact answer. And that's kind of the thing with trigonometry. Well, not trigonometry, but just all this as a whole, is that we want to give you options to find your missing values. So I'm going to write it out one more time. Tangent of some angle theta is going to give us the ratio, the opposite side in a triangle divided by the adjacent side of the triangle, all in reference to this angle over here. Sine is going to be equal to the opposite side of that reference angle divided by the hypotenuse. And then cosine of some reference angle is going to be the adjacent side divided by the hypotenuse. So I'm going to give you guys some information, and then I'm going to cover up some of the information and I'll tell you what we can do. So we're going to have x over here. We're going to have I want to use fake ratios. Okay, you know what? I'll do 22 over here, and we'll do 2 and 5. And because 22 is over here, we can quickly solve. So that's 180 minus 90 minus 22. So 180 minus 90 minus 22. So it gives us 68. Now there's multiple ways to solve for that x. The first way is going to be the Pythagorean theorem. That's a squared plus b squared equals c squared. Now, this is a reference triangle. I'm just going to draw real quick. We'll call this A, call this B, and we'll call this C. Right? C is going to be our hypotenuse, and then A and B are the legs of the triangle. So to solve for that x, we can plug in what we have over here. We have 2 squared plus 5 squared is equal to x squared. 2 squared is just going to be 2 times 2, which is 4. And then we're going to add 5 squared, which is 5 times 5, which is 25. We're going to keep that x for the same. Then we're going to do 29. So we're going to add 4 and 25 together. It's going to give us x squared. Then we're going to square root both sides. So the square root is going to cancel out that square. And we're left with x is equal to the square root of 29. Or to put that in the calculator, let's take the square root of 29, and that gives us approximately 5.4. We'll round up to 5.4. So that's one way. And I'm going to have to go on to the next page. So, you know what? I will draw the triangle again. So I'm actually going to just put everything on here. I should have made a new page since it's going to be a bunch of work. So I'm going to quickly go through it again. We have some reference triangle here. This side is A, this side is B, this side is B. The Pythagorean theorem tells us that if we have two of these sides, we can solve for the missing side. A squared plus B squared is going to always equal C squared. A squared plus B squared equals C squared. So you 2 squared plus 5 squared is equal to x squared. That's 4 plus 25 is equal to x squared. 29 is equal to x squared. Square root of 29 is equal to square root of x squared. Those cancel out. X is equal to square root of 29, which is also equal to 5.4. So that's method number 1. Okay. Method number 2, we're going to use cosine. So we can do cosine of either angle, and as long as we set up the ratio properly, it will still work. So really, this is kind of like the 2 methods in 1. Call it 2/3, and I'll show you both ways with cosine. Let's take cosine of 22. That's going to give us the ratio of 5 over x because 5 is adjacent to 22. Let's do some quick math to get x by itself and get our answer. So we get that x is equal to 5 divided by cosine of 22. We're going to plug that into the calculator. So let's do 5 divided by the cosine of 22. Would you look at that? We got 5.4. It's perfect. And now we're going to do the second version of cosine, where instead of the 22, we're going to take 68. So let's do, I'm going to put it right here, cosine of 68. That's going to be equal. So remember, now that we're using 68 as our reference angle, the adjacent side changes. So we have 2 over here now as the adjacent side. So it's 2 over x. And then once again, we're going to do some quick math to get x by itself and solve the problem. We get that x is equal to 2 divided by cosine over 68. Let's plug that into our calculator. 2 divided by cosine of 68. So this one, the number is a little smaller. So we get 5.33. But that's okay. It's still really close to 5.4. So we'll keep it at 5.3. Okay. This is the 4th and 5th way, and I'm actually going to do here. I'll split it up so I have plenty of space for both of them on the same page. So they're both going to involve sine. right? Sine, we can use the same exact way we did with cosine. If we take sine of 22, we're going to set up our equation. So we do sine of 22. Now we're focused on the opposite side and the hypotenuse. So sine of 22 is going to be 2 over x. Some quick math to get x by itself, solve the equation. Cancel those out. We'll do x is equal to 2 over sine of 22. We'll plug this in the calculator. 2 divided by sine of 22. So I have a similar situation where we get 5.33. So we'll say that x is equal to 5.3. Now we're going to focus with the other angle with sine. Sine of 68 is going to be equal to, remember now we switched angles, so now the opposite side changes. So now 5 is the opposite side. So it's going to be sine of 68 is 5 over x. Let's clean this up. All right. We end up getting x is equal to 5 over sine of 68. So we'll plug that in our calculator. 5 divided by sine of 68. And that gives us 5.39, so we'll round up to x is equal to 5.4. So we have technically five, different ways to find the same value using different parts of information. So remember, in order to solve for any part of a right triangle using the trig ratios or Pythagorean theorem, you're always going to need two pieces of information. Okay, I know we just had kind of like a giant moment of silence. I didn't mean for that to happen. I wanted to write all of this down. Okay, so to kind of start off, to kind of round things up, when we use trig ratios, it's completely dependent on the information that we're given, right? Let's assume that we're always given one angle and we're given one side, right? So say, and I'm going to just kind of like use my fingers to block it out of the way. if we're given an opposite side and theta, right? And we want to solve for this side over here. So let's say we're solving for this side over here. You can't use sine and you can't use cosine because it doesn't involve the hypotenuse, right? Automatically, you can't use cosine because you have two unknowns. The hypotenuse isn't even given, and then you're already needing to solve for the adjacent side, right? You know what? Actually, I'm going to write down the different scenarios in which you can use each trig ratio, like specifically. I think if I just keep doing this back and forth, it might not make enough sense. So let's try this instead. Okay. So if we're in a situation where we have this reference angle and we're given the opposite side, right? These are two known values. Let's assume these are two known values. And x is something we want to solve for. We have to use tangent. We have to use it. Okay. Now let's say there's a scenario where you're still given the same angle, but now you're solving for the opposite side and you're given the adjacent side. This is another situation where you need to use tangent. Even if you are able to find the missing angle over here or here, because there's no use of hypotenuse, we just can't use any of the other ones at all to solve for that missing value. Let's if we have a triangle like this, a little bit. Now, if we're solving for x and we're given the adjacent side of this reference angle, there's the first option we're going to have is we can use cosine, right? Because cosine specifically works with an adjacent side to the angle and the hypotenuse. And we're given an angle and we're given an adjacent side, so we can solve for that x. Another case in where we can use cosine is going to be when we know the hypotenuse, but we don't know this side over here. We can use cosine theta again, because it's the same set. Now, when can we use sine? We can use sine here as well, but we have to solve for this missing angle here. So I'll call this theta sub 2. I'll call this theta sub 2. In this case, we can now use sine. Right? Because now this is the opposite side of that angle. It's different. Now it's opposite side. So opposite over hypotenuse. Right? We have this new angle here. We still have the same side that we're given, but now it's opposite, so we can use sine and solve for that missing x in the hypotenuse. It's the same situation down here. This is some new angle that we found. Now the side that we're given is the opposite side of that angle. Then, let me these in terms that the reference angles have. So sit over x, this one over here, and this one, x over the adjacent side. This is the adjacent side over x. This is the opposite side over x. This is x over the hypotenuse. And this is x over the hypotenuse as well. Okay. I think that covers just about everything, at least in kind of general terms. I can do more practice examples. I can just do a whole video about practice examples. If any of my students would like me to just do a whole video of you doing practice examples, please email me after seeing this video. Also, it is my first video, and I know my voice is like really, really, really monotone. So I'm sorry if I put any of you to sleep. I will, I will try to make better videos. Uh, but in the meantime, this is the best I can kind of do. I'll try to see if there's a setup where I can just instead of using the document camera, I can just draw or like write on the screen, and that might maybe would be easier with conceptualizing stuff, or I can like set up with my slideshow. But if you have any feedback, please email me. And if you're not a student and you're just watching a random math video, I hope this was helpful, and I hope my monotone voice didn't put you to sleep. Okay, bye bye.